This video is a demonstration of the AeroShield simulation tool. This utility allows the user to position remote spectrum monitor probes on a map and estimate how well the placements cover a given geographic area. So as an example, we'll use the Heathrow Airport area. So we use, as an example again, 4 probes placed around the airport, and then we'll simulate a drone incursion to examine just how well that system detects and tracks an incoming drone. We'll then cover the method for making an offline map using Map Puzzle to embed GPS coordinates into either a JPEG or PNG picture of the airport, and then load those maps into the simulator and place the different RSM ports. We'll then add a drone flight path into the area under protection. To make the offline map, launch a browser and search for Heathrow Airport. Here we're using Google Maps. Right-click somewhere on the map, select the GPS coordinates, and these will automatically save to the clipboard. And we'll then later paste these coordinates into Map Puzzle. Select a map type here. Google Maps are selected for this example. Once the map type is chosen, you can then preview the map. Map Puzzle lets you move the map in any direction to get it well centered. The map can be made larger or smaller by changing the height and width parameters here. By increasing these numbers, we'll change the size from 2 kilometers to 2.6 kilometers. And now we'll download the map. After the map download is completed, the first 4 coordinates are copied here and then will be pasted later in the map that we use for both the simulator and the demo program. So here's the simulator and demo program. So we go up and view the map, and then we bring in the map and just paste right here, and all the 4 coordinates are incorporated into the map, as you can see here. Now in the demo program, we go to the map icon, import the map, and it's automatically displayed here. The RSM probe positions are positioned on the map by right-clicking and then copying the GPS coordinates and pasting in the GPS coordinates column on the left. We can also measure the distance between one probe and another by right-clicking and moving your mouse to trace to another position. In the bottom you can see a meter determination. And then place a probe in that second position. And then we'll go on, measure. You can see on the bottom again the meter position, how many meters distance the next probe is. Place your probe. And we'll place one more probe arbitrarily in this location. You can add more probes if you like, or use a minimum of 3 probes in order to do the simulation. Next, we add the RSM icons on the demo program. We click on the plus sign on the left here. Automatically it's listed RSM 1, 2, 3, and 4. URL is always 127.001, and click locate to get the GPS coordinates that were determined in the simulator. And we go through this process for each of the 4 probes in the demo program. Now in the drone incursion into the simulator map, and what we do is left click, double click for each position that the drone is to fly into our secure area. And we'll just go through arbitrarily. You can pick whatever flight path you want, and you can also perform some worst case analysis by moving the drone path perhaps outside the network or far away, and see how the AeroShield software performs. So now that we have our path, we can right click in this area right here, and we could double the drone points. We can also smooth it out a bit if we want, so it's arbitrary how we'd like to do that. So each time, each GPS coordinate will show the precise drone position as we go through the map there. Drone parameters are set here: frequency, bandwidth of the drone. Typically the bandwidth is 10 or 20 megahertz, but it's arbitrarily, you can set up whatever you like. Amplitude we'll leave as is. The check mark there is you can turn the power on and off. You can also add noise to the signal. There's both square noise and Gaussian, and you can set different levels of that noise. The drone signal duty cycle is set to 100%, but we can leave that as is. You can set it to 50%, 20%, whatever, to exercise the drone that way. Before starting the simulation, we'll look at the coverage mapping function with AeroShield. It gives you an indication of just how far the network can see an incoming drone. Here we leave the setting at 500 meters, so each drone can physically, quote-unquote, see the signal as far as 500 meters away. And you can look at as the drone comes in from different angles, the extent of the coverage that you can reliably see. And that's assumption of a 500 meter radius for each probe in terms of what it can see for the drone signal. Other settings to note in the simulator are the track reset delay, basically how long you wait until it resets and goes to another loop of a signal, and then IQ download delay. Typically if you have fiber or very fast backbone network, that's going to be 0. And then number of tracks per second we'll set at 1. So each iteration will be 1 second, and then hit start, and then hit start in our demo program. Before the program begins, it'll cycle through each band of each probe, so 2.4 and 5.8 gigahertz to set the mask, and then it automatically goes into monitoring mode. And we set the simulator to begin, and you can see with each track here, we're still kind of far away from our network position, so we won't get that accurate until basically the drone comes in kind of fairly close, within that radius that we examined with our coverage map. So you can see we're starting to get a good track with that bullseye coming into the network. And it'll just cycle through each GPS position outlined in the simulator by the yellow rectangles, and you can see in the actual demo program the position moving in the probe network. By clicking on tracking points here, you can change the amount of the moving average settings as well as the line thickness. You can look at individual plotting points as we see there. So these are different parameters that you can play with to get different modes in terms of the track, in terms of the actual smoothness that you like to see in the path that the drone takes. I'll speed this up a bit so you can see what happens after the drone moves out of the network. The probe icons active in the map are shown in red, and the one not used is in green or bluish green. So you can see you're pretty far away from the 3 active probes. The drone actually became pretty far away in a straight line between 2 of the probes and far away from the 3rd. But it did pick the signal back up when it came a little bit closer into the network. I now stop both the demo program and the simulator. By clicking on the actual track here, you can see the actual flight path of the drone is reappears. Right-clicking on this track brings up various ways to save the file. We export to KML, save it in a certain directory. To move probe positions, move your pointer to the GPS column, hold down the control key and move the wheel to go up and down, or hold down the shift key and move the wheel to go left and right. And we can update the probe positions here. Right click and then update positions, and you can see the probes in the demo program match now what the changed probe positions in the simulator are. With the new probe positions, we'll take a look at our coverage map again, this time setting the radius to 800 meters rather than 500, and we'll look at the expanded scope of the range in which the system can detect and track drones. Coverage range is a lot larger. A lot of the range depends on RF environment, antenna height, multipath, and other impediments to the environment. Here's a side-by-side comparison between the two settings, 500 and 800 meters. That's it for our video. Check out the user guide for a complete description of the simulator and its capabilities.